In the 21st century, the real-world problems that exist are interdisciplinary in nature.
Today, solving many critical world challenges requires sophisticated new materials and processes that can only be discovered and developed through interactions across science and engineering disciplines.
Organic electronics or printed electronics is an emerging technology. It impacts a lot of different areas that have a deep consequence on society. Just name a few: energy, for instance, healthcare, information technologies, security. All these are really important. Georgia Tech likes to not only be a leader in these different areas, but also kind of contribute to shape that industry.
Historically, electronics relied on inorganic materials such as copper or silicon. Now a new generation of technologies is emerging based on carbon-based materials. Like the molecules of living things, these organic materials have some distinct advantages over inorganic semiconductors, such as low-cost production, mechanical flexibility, and environmental compatibility. Keeping up with today's demand for newer and better materials is the charge of the Center for Organic Photonics and Electronics at the Georgia Institute of Technology, where the focus is on using organic polymers and small molecules in the next generation of electronics.
We actually created a strategic plan that really touched on education, research, knowledge transfer, diversity, and creating a global effort.
The center brings together multiple expert perspectives from many disciplines across Georgia Tech's campus, including 30 faculty members from 7 schools, and partners them with an international network of leading universities and corporations in this field. All of this brainpower allows the center to take on research addressing some of the world's most critical challenges and produce graduates ready to provide innovative solutions.
Interdisciplinary research is part of the DNA of Georgia Tech.
When it comes to device fabrication and device measurements, those are interdisciplinary functions. So you need to have some electrical engineering background, some mechanical background in order to do these devices. And that's something that this center has.
It's absolutely essential that we change the way we train our students so that we give them an appreciation of having an approach that is multidisciplinary rather than just specialized in their field of expertise. The students have an enhanced experience because they benefit from some of the infrastructure that COPE is providing. We give some COPE fellowship to the best students, so this is a way to recognize their efforts.
The Center for Organic Photonics and Electronics really helps to make those connections between people that you can collaborate with, and it makes it easier to find people to work with.
We're really trying to educate our students in getting the broader perspective so that when they synthesize a new molecule, they have already a perception of which device it might be useful for.
Here we look at organic electronics, where we work primarily on the packaging and looking at the lifetime issues that would occur with flexible organic electronics. The strength of the center is the fact that we have people who have expertise from what I call the front end, the design of the molecules, understanding how the molecules behave, the manufacturing or the synthesis of the molecules, all the way through packaging and looking at lifetime.
They have unique facilities at Georgia Tech and a unique way of organizing themselves through COPE, which makes it fairly seamless. There's a real sense of structure around the science as opposed to the departments themselves, and that's really helpful.
While we continue to see science as the driver for answering the fundamental questions that will enable technology, we've answered enough of the fundamental questions that we can actually create technologies and now work to transfer these technologies to companies.
ConocoPhillips wants to look at alternative energies such as organic photovoltaics.
We've had several programs in the fields of OLEDs, materials for OLEDs, materials for OFETs, field effect transistors, printed transistors, and also we had some programs on materials for organic photovoltaics. So we really enjoyed the relationship, not just because of the science, but also because of the people. They help us leverage the network that they have.
This is kind of a one-stop environment where you have a chance to work with faculty who have expertise in all the different core areas that are needed in order to go from a concept to the commercialization of a new product. Georgia Tech is well positioned in this area to make really big impact on the research and the technology of the 21st century.
Developments being made now hold promise for new products in exciting areas like telecommunications, lighting, healthcare, energy, and information technologies industries. The people of the Center for Organic Photonics and Electronics at Georgia Tech and its partners are at the forefront of making these technologies an everyday reality.